Hi guys, welcome to another Learn Electronics Repair video. A few weeks ago I was looking at a graphics card that wouldn't detect in the PC. All the voltages were present, everything seemed to be okay, but it wasn't being detected. And one of the things I wanted to check was whether or not the clock, the 25 megahertz crystal, which is on all graphics cards, was working or not, because without a clock the GPU can't run. And I determined that using an oscilloscope. One oscilloscope. So I got my oscilloscope probe on the crystal and I can see that it's not running. I then mentioned the fact that crystals themselves really don't fail. It's probably a failure in the chip that's driving the crystal, in other words the GPU. But we replaced it with another one and it still wasn't running. And again, I knew that because I had the oscilloscope probe. And of course, attached to the oscilloscope probe was the oscilloscope. But I know you guys, a lot of you, don't have access to all this equipment that you might need. But when I say need, probably it's more like equipment that you want, because there must be a cheap way to work out whether a crystal, A, is any good, and B, is it oscillating. So testing the crystals out of circuit to see if they're good, and for that matter, in fact, measuring them, see how the frequency what they're running at is, or if it's any good. So I had a look around based on this, and I had a look on AliExpress, and I came up with an idea that might basically resolve this problem for us, and we can all check these, and not only crystals on graphics cards, but also on motherboards and other items as well. So I found these 1 Hz to 50 megahertz crystal oscillator frequency counters. And this, with the postage, cost me €6.87. And this is the item. So, from what I understand reading the description of this, it'll measure frequency from 1 Hz to 50 megahertz, which is more than enough that we want, I would think. And it can also measure the oscillation frequency of most commonly used crystals, auto range, without manual switching, and a few other things. I think it says it can withstand up to 30 volts on the inputs. That's good. And it comes basically as a set of bits. And if you look here, there's a socket here, so you can take a crystal and stick it into that socket and it will measure the frequency of just the crystal as a component. Or, as I understand it, you can connect leads from here and probe your circuit board and measure the frequency of an oscillator that's running. So that's what we have. It comes with a USB cable, which from what I can see in the description is just a charging lead. Not charging, there's no battery, it's a power lead. But you could run this from battery as well, which actually would be quite advantageous, as we'll talk about later. So this is what I found. You can see what it cost me. So it was less than €7 with the postage, and a few days ago it actually arrived. Let's have a look to see what we actually got. And what we got is a bag full of bits, which looks quite interesting, So let's open this. We've got to open this up and let's see what's in it. Okay, here we have it. So this is all the bits that were in the box. PCB, some instructions, the welding installation, debugging. Little schematic, so we have that as well. So if it doesn't work, we should be able to work out what's wrong with it. I mean, this is Learn Electronics Repair after all, Oh, nicely bent one of those bits. Not too many bits there, so we'll stick this thing together. I think this is the little case that it comes in. So let's have a look at this as well. So little bits like. Oh no, it's perspex. Basically, it's perspex. Okay, there's all the bits. So let's see. There's the instructions. So they basically just show you which bit goes where, and they show you the value of all the bits. Oh, and some are saying that the yes, black for the negative, and so on. Okay, so I think we can get this put together. So let's make a start on this. It's a long time since I built an electronics kit. Well, back in the day, the way we would do this is first of all start with all the components which are closest to the board, which would be the resistors. So the first thing we'll do is stick all the resistors onto our board. There's all the resistors then. It's good practice, by the way, when you're doing something like this, to position all the components in the same direction so the color code reads the same way. It just makes life easier. Obviously the vertical ones read this way and these read this way, you know, left to right, which is the normal direction of reading, unless you're Arabic, of course, and then it's the other way, yeah, and then unless you're Chinese and it's vertical, but you get the point. Yeah, you get the point. So we actually got one spare resistor, but it doesn't go anywhere. I've counted how many were on the sheet, and I've counted how many I've fitted, and as far as I can see, they're all there. So now we'll carry on with the diodes, which are the next ones flat to the board. So we see there's one goes here, and there's 4 go here, and the diodes are all listed here. They'll all be the same type, I'm sure. Yeah, 1M4, 148. Okay, so we now have the diodes fitted. They're all mounted the correct way round with the black stripe towards the stripe on the PCB. I have to say this PCB is really nice and easy to solder, by the way. So now we have a handful of little capacitors. So let's get these on there. I think they're all the same value again. We can have a look. No, they're not all the same value, so I just have to make sure I put the right ones in the right place. Now we have the what look like 3 transistors and the crystal. So crystal, 20 megahertz crystal, and U1. Okay, so we have a voltage regulator, which is U1, and U2 and U3 are NPN transistors. So if you look at these, you can see 2 of them are actually the same and one's different. It even says 75058. It's got the number on that's marked on the parts list. So this one is U1, and then the other ones are U2 and 3 in the crystal. Very nicely marked on the PCB again, so easy to put these on in the right place. So they're all in place. This one was slightly crooked. You probably, even on the speeded up video, saw me just straighten that up a little bit. It was really bothering you. You could just unsolder it and solder it straight. But I'm happy enough with that. So now we go over to the microprocessor chip. Now, quite nicely with this, and quite surprisingly actually, considering how inexpensive this was. Now, let's admit it was cheap, yeah. How cheap this was. They actually provide us with a socket for the processor chip. That surprised me a little bit. So a little notch in the socket goes to the notch on the board and goes to the notch on the chip. Okay, that's nice and flat. It's in there. We'll insert this in a minute, the chip, put it on last year. So, okay, next thing now is going to be just to insert the socket for the crystal tester. We've got the jumper which goes here. We've got the little terminal for connecting the wires for testing on board, and we have the power socket. So let's get all these on our board. So now it's just the LED display and the switch and the chip to fit in. So let's get these last components fitted. So there it is, all assembled apart from the fact it needs fitting into the case. So we can just have a quick look at it here. So yeah, that's the only instructions. So yeah, this is what I was saying, put the components all low down on first. Yeah, the after completion of soldering, plug in the chip. Yeah, just check if whether again such as anti-bleed, whatever that's supposed to mean. And then you're saying it has a self-test, so effectively when you power it up, the fourth digit should display 0, which says it's successfully installed, basically. Yeah. Mentions the jumper now. So this jumper So right, so this jumper selects between whether we want to test a crystal out of circuit or if we want to measure a frequency in circuit, and it's saying that it can't be more than 30 volts, otherwise it'll damage the frequency meter. And there we have finally the schematic. So what I really need to do now is just figure out how to put this little case together with some bolts and bits and bobs, and I'll just do it off camera because you're going to laugh because I'm going to make a mess of it, I'm sure. Okay, let's see let's see how it works out. Yeah. That's all put together again. It's a little bit fiddly, but it wasn't too difficult. The spacing of these is such that it only seems to go together one way anyway, which is quite handy, so you can't really get it wrong. The only problem I found is that the 4 screws that hold the PCB in place are too short. You know, they're like this size. And even by trimming all the legs where I'd soldered, I couldn't get it to sit. And even now it's slightly leaning down on one edge. It was very difficult because there's a gap effectively. It's very difficult to get the thing to sit straight, but that's not really a problem. The little jumper then. So in this position, it's for testing in circuit. So if you want to see if an oscillator is running in circuit, we put it into this position. And this is the in and ground probes. And in this position, we can plug in crystals and test them. So it is a dual purpose device, which is quite handy, I think. This is quite well insulated and covered. It comes with a power lead like such, but I'd suggest connecting this to like a little 5-volt power pack, or even use a battery with it. Yeah, like I'd have to try it with a 6-volt battery, but it has a 5-volt voltage regulator on here, so I'm sure it runs fine. And we could plug a power pack in, I think. The reason being that if you plug this into your computer or something, it's effectively grounding the device. Whereas if we connect into a little like wall wart, as the Americans call them, or just a power pack as I call them, or fuente de alimentación, which the Spanish call them, then it's isolated. And we could then effectively, I think, even use this for testing, like if pulse width modulators are running and power supplies, because it's isolated from ground. So we could use this even on the hot side, I think, hot ground, and testing if we want to know sometimes as a a chip oscillating. And it says it'll up to 30 volts, and that's more enough for any signal, I think. I mean, the 30 volts is the voltage between ground or hot ground and the chip that you're trying to measure the output from. And if we did blow it up, well, it wasn't very expensive, was it? But I don't want to be damaging it. Okay, so let's see if it works, and let's see first if we can measure some crystals with it. Other than these 4 pins being too short to easily fit the PCB, I think the construction of this is very good. Actually, it was easy to put together, and it's surprising you can make something like this for less than €6 and ship it all the way from China to the Canary Islands, which is kind of like the middle of nowhere, and still make a profit. Yeah, but I suppose the question is, does it work? Yeah, does it work? So I've got the thing. I've actually got it attached to my PC at the moment. Just it's the easiest place to find a USB power, and I'm only going to test this on low voltage circuits anyway. But yes, it comes on the 4th digit. It says 0, which is what it said in the manual. So let's see now if we can actually test some crystals with this. I've put the jumper into the position for measuring a crystal. Here's a crystal, and it says on it 27. I'm assuming this is 27 megahertz crystal. So let's try and stick it into the little socket and see what it actually does. Something's happening. Let's see what it does. Well, the first thing I'll say is it's very fiddly to do, to actually get the crystal into the thing. Oh yeah, 27.059. So it certainly works, but it's fiddly, and you wouldn't do it with like a little one like this, and you certainly wouldn't do it with a surface mount one. But I think we can quite easily get around this little problem. So let me just have a quick dig around in my box of bits. I've just taken these just bits of old IC sockets basically, yeah, and I just cut a piece off and then just stuck the 2 bits together like so. And I can now insert this into the tester, and that should allow me now to easily test crystals. Yeah, so that's just so that way above that now. So let's give it another go. We'll just get the power in 1 moment. Okay, power it up. It says 0. So let's take this crystal. Let's see what this one does. So we'll just plug this into the tester. And it's saying 20.063. And what's the markings on this one? Oh, it's a 20 mega. Oh, it might be even closer than that actually. Let's just get the microscope and let's have a look what this is. Okay, well it says 20 and then it says A180. But I mean, you know, I think this thing's close enough. I mean, we want this basically as a piece of test equipment. I don't think I'm too concerned of exactly the crystal frequency. I just want to know if it works or not. So this reading 20.063, I think that's fine. Oh, digit slightly done there. What's the test button do? Quit. Oh, this has some functions that I'm not quite sure what they are. NOP SL, no PSL, add, subtract, 0. Table, quit. How does 0 work? Take the crystal off it. How does 0 work? 0, do we hold the button in or something? Oh yeah, it flashes. I wonder if that's 0, is it? Okay, let's have a look now what we've got. So 19.997. it's very close, you know, to 20 megahertz. What's this thing? This is what we measured before. 26.994 is a 27. Let's try a surface mount one to see if I actually, if I can just hold it against the thing now. Can I get a connection on a surface mount one? Yeah, I can. It's 12, isn't it? That. What's the frequency? Yeah, it says it's a 12. Oops, sorry, microphone bumped into the microscope. Yeah, microphone in the microscope. Yeah, that was a surface mount one there, 12. Yeah, that's working. I mean, I'm happy enough for what this cost me. That's good enough. That's better, well, almost as good as I expected. That works. So let's see if this also works for testing in circuit. And I think we can probably use this for testing crystal oscillators, obviously. But I think we can also use this for testing like pulse width modulator controllers, VRM controllers. Is it driving the MOSFET gate? That sort of thing. So let's try on a working board and a working, or maybe even a non-working graphics card, and let's see what happens. I would probably with this myself, if I decide to keep on using it, which I may well keep on using it, is probably to fit a connection like this, a BNC connector, and I can just attach a scope probe to this, and that wouldn't be difficult because you can see that I can get the end of this or one of these. I think this one's actually been broken off, but we'll solder a stiff little bit of wire into there, like a leg resistor, yeah, and just put a little bit further in, and I'm sure I can actually just glue this in place so that it sits flush back to here. And I can just attach to this a tag, there's one already on there, or washer, with a ground wire, another stiff bit of resistor leg into the ground. And I'm sure I can easily fit this on there, use the scope probe with it. But because this is about doing things as cheap as we can with this, I'm just going to do it the ghetto way. So I'm going to just take a bit of wire in here, and on the end of it I've just soldered like a piece of a leg cut off a LED because it's nice and stiff. A little bit of heat shrink, so I just hold this in place, and I've got another similar wire for the ground which just has a crocodile clip on. So I'm going to attach these wires and let's see how this works in circuits and see how useful it is as a fault finding device. First of all, I just want to find a few frequencies that are running. This is the motherboard that we fixed on the video yesterday, so we'll use this one. So here we have a crystal, and if I just go down to the pins, there's always two capacitors next to a crystal, and the middle ones will be going to the legs of the crystal. And you can always turn the board upside down, but we can get on there and you can see it's oscillating. If I just I can probably just get it to actually synchronize on it. I'll go again on the other side. Yeah, I'm sure you can see that it actually is oscillating. So we can see on our scope this crystal's oscillating right there. Can you see it now, like a frequency signal here? I can't get more wide than that, I'm sorry. As close as I can get. So now that crystal's oscillating. And there's also a few more signals around here we can check as well that are coming out of the clock generators. So this is the board view for the motherboard that we have here. And this is the clock generator chip. And here, if we look, this is the crystal I was just testing. And you can see the two capacitors are here and here. And there's a resistor in between which isn't fitted on our board. So I was actually checking here and here, which is both ends of the crystal. And I can see on the oscilloscope that is oscillating. My oscilloscope, the analog one, is a 100 megahertz scope, by the way. This is the clock generator chip. And if we look, we can see we have some interesting signals. So we have a 33 megahertz signal here, and we have a 33 megahertz signal here. So we can check again on the scope to see if these are actually oscillating. And then let's have a look on our meter. So we can see that the junction of these two resistors here is one of them, so we can test here. And the other one we can test on this capacitor here. I'll use the oscilloscope again first, just to be sure we do have signals here, and then we'll test our gadget. So this is one of the test points that, here. I'll just get in so you can actually, I'm on it. Okay, so I'm on that. I slipped off it one moment. I'm on that one. So let's just see what's actually happening here. And yes, we have a signal, you can see it quite clearly on the scope. Okay, that's one of them. And the other one is here on this component. Let's have a see what we have here. And that one doesn't seem to have a signal on, so we'll just check the other one. Let's try with our makeshift probe, the LED leg cut off. So by the crystal first, so I'll just get onto one of the terminals. It's hard for you to see my things, I need to hold the thing in place. So what do I see? Well, I've powered it on and I don't see anything. It's booting up, but I don't see, it's giving me a picture, I don't see anything. Try the other pin. Okay, I'm definitely on this. You read something for instance, let's boot it up. And I don't see anything. So the crystals in circuit, obviously, this thing just can't detect. It can't detect them. Let's try the junction of the resistor. I'm on the resistor. So this is on the 33 megahertz clock, which was a larger signal on the oscilloscope. What happens if I try here? Well, it read something for an instant and went off. Try again. Read something for an instant and went off. The thing's booting up. So I think we have to say that's a failure. This cannot see clock frequency signals on the motherboard. There is another possible use for this little gadget which I mentioned earlier, and that's to see if VRM controllers are driving the gates for a MOSFET. There may be occasions when you want to know has the MOSFET got any drive and you don't have an oscilloscope possibly to check. So let's see if we can find some MOSFETs. Well, this is the memory VRM. I'm not sure about this one, but I'm sure that these here are the high side and low side MOSFET. So let's just get onto the gate of one of them. I can easily get to this one. So I'm on the gate of this one. Let's start this up and let's see if we can see this VRM oscillating. And yes, we can. And it's, I think, running at 310 kilohertz. And the thing's booted up. So this will tell us if a VRM is running. And I'm assuming we can go to the gate of the, that's probably the high side. I'm guessing this is the low side. Does it work here as well? Let's have a look. Just hold my little makeshift probe against it. So let's turn on. And yes, it does the same 308 kilohertz. So this will definitely tell us if VRMs are running. Let's have a look at the VCore one as well. So that's the VRAM. This is VCore. It's just under the edge of the heatsink here, a bit hard for you to see. But I'm on the gate. So let's see, is this one? Oh no, just slipped. Let me go again. I'm on the gate. Is this one running? it's not very easy with this probe. I would make something better than this. But yes, it is, and this one's running to 116. Just switch it off again, completely different frequency. So yes, this will tell us if the VRMs are oscillating. We found then the limitations of this little toy. But there's a couple of things we can try first. First of all, we can give this a chance. Let's fit the BNC connector in here and let's just attach a scope probe to it and then see if it can measure these frequencies on the clocks on the motherboard. It may just be that this is not going to do it. So we'll try that. And there's another thing we can try as well. I have my Fluke Multimeter, which you see me using a lot of times on the channel. This has a frequency hertz range, but this will only measure up to 20 kilohertz. So it's pretty useless really when it comes to measuring frequencies. But I have the other multimeter which you also see me using, which is the Aneng AN800. Now this again has a frequency range, but this can read up to about 150 megahertz or so. But I haven't really ever used it for that purpose. I'm interested to see is, can this see the clock frequencies on the motherboard? Does it have the sensitivity? And also we can check this on the MOSFETs as well, on the VRMs. So let's try those. So first of all, we'll just check this and see if this will do the job, and then we'll try attaching a scope probe to this and see if this will do the job. Here's our multimeter on the hertz range, frequency range. So let's just start our motherboard and let's have a look to see again if we can see these oscillators running. This has a frequency range to do it, but I suspect it doesn't have the sensitivity to do it. So this is directly on the 20 or 25 megahertz crystal, and it's not doing anything. Okay, we're not seeing anything there. The thing's just booted up. We can go on to the signal coming from the clock chip, and again this is a 33 megahertz and it's just not doing it. We can try what we just tried with the other little meter for checking the VRM. So we can just go onto this VRM and it's reading 311.8 kilohertz, which is similar to what we got on the other one, and I think on the CPU VRM it was at 150 or something like that. 116 kilohertz. So this will do what the little tester will do. And to be quite honest, for working on high voltage equipment, I was talking about on the high voltage side of power supplies to check the pulse width modulator running, this is safer, but the other one would do it. So again, we've proved that even with this multimeter we can't see these clock frequencies. Only the oscilloscope is sensitive enough out of the equipment we've tried to be able to do it. But we can give it a last chance. So let's connect the BNC to this. Let's attach a scope probe to this and see if that will do it. Again, it may be down to the meter leads and not the meter that's stopping me from seeing these clock frequencies. Here's the test meter with the modified connector on for the BNC. So I've now got a scope probe. So let's have a look again. Let's check first on the crystal itself. And it now kind of like reads something and goes off. Does it again? Other side. But no, it can't measure. It can't read the frequency. We'll go again. We'll just switch it off. Let's go to the clock generator IC. Switch it on. And yeah, it can't. So it can't. That's the answer to that. There's one more thing I'd like to try, then let's come to a conclusion. So I'm going to see if I can attach the BNC to my Aneng meter and if this will read them. I've attached the BNC to the meter. You can see how I've done it. So we can give this a go. The scope probe's on ×1, by the way. It was on ×1 when I was trying the other little frequency meter, to see whether it could see these signals or not, and it couldn't. So let's just try with this now and see whether this actually will make a difference. Power on and on, and let's see. So we'll go again for the crystal, and no, it doesn't. They just don't have the sensitivity to do this. I can see that. Switch it off again. Now let's just go for the other one. This is the one coming out of the actual clock IC. And once again, it can't see it. So yeah, that really proves the fact that the only way to do this, as far as I can see, is with an oscilloscope. We have to have a conclusion to this video. So this little thing, it obviously can't read the clock frequencies on the motherboard, and I'm sure a graphics card is exactly the same thing. But there again, neither could the test meter either. It seems the only way to do that is with an oscilloscope, and that will be a topic of another video. Let's see how much money we need to spend on oscilloscopes to actually get something we can use. So to this little thing, it's fine for measuring the frequency on VRMs, that's for sure. And if you have a multimeter that doesn't have a frequency range, or which only goes to 20 kilohertz like this one, then it's worth having for that. If you've got something like this is much easier to use. Basically, it's certainly safer on high voltage sides of power supplies where you may find a pulse width modulator and you want to check it. Regards measuring crystals and testing crystals, it does it perfectly. So I've got to give it a rating out of 10. And first of all, I'm going to give it 5 out of 10 because it does test crystals. And when I bought this, it specified it had 2 uses, one for testing crystals and one as a frequency counter. So 5 out of 10 automatically, because that function it does, and it does it perfectly. I'm going to give it another 1 out of 10. I'll give it 1 more out of 10. I'll give it 2 more out of 10, but this is not totally safe for connecting high voltages to. And it doesn't do anything that this couldn't do. So yeah, 6 out of 10. But that all depends. If you don't have that functionality on your multimeter frequency and you want it for what this is doing, then for less than €6, you know, I mean, it's a lot cheaper than buying another multimeter. Okay, guys, I'll let you somewhat come to your own opinion on that one. I've mentioned mine. It's now up to you. Hope you enjoyed it. Comments in the section below, please. And I'll see you all soon on another video.